Good afternoon, peeps! Welcome back to another video here on the Off-Grid Garage. A nice, beautiful and sunny afternoon. Well, at least it is afternoon here. I'm not sure what time it is when you watch this. We had some massive thunderstorms rolling through this morning. So I had to wait for the video until this is all cleared up. Beautiful. Yeah, beautiful sunshine again. What better can we do than building a battery today? Well, yeah, as you may know, I have two of these AGM lead acid batteries in my solar gate at the front of the property. And these batteries worked well for the first year, and then it started to fail. Because if you discharge them too much, well, they lose capacity, the life cycle goes down, and eventually they will die. So quite a while back I thought, well, how can I replace these ones with better batteries? A better option than lead acid batteries. I mean, this is a 100-year-old technology. We've got the AGM batteries at the moment in the front, and they are working a little bit better than the normal lead acid batteries, but still is the same principle. See, this one has a capacity of 7.2 ampere hours, but if you are using this 7.2 ampere hours every single cycle, well, you probably get only 200, 300 cycles out of the battery, and then that's it. To really prolong the life of these lead acid batteries, you should use only half of the capacity, maybe even less than half of the capacity, to get a decent life cycle out of them. And I really don't have much influence of how much capacity I can use in the solar gate. It all depends on the weather and how much solar power comes actually in to recharge the batteries. So this is very hard to monitor and maintain. And that's why I thought I replaced the lead acid batteries in the solar gate with lithium ion batteries. These are from old laptops, recycled ones. And I quickly show you what I have done here with all these piles here. I have written down the date and the capacity in milliampere hours and the internal resistance in ohms right on each of these cells. Well, how do you get these numbers? Well, you get the date from your calendar, and the capacity and the internal resistance will be coming from your tester. I have used this Litokala Engineer LI500. This is actually a tester for 18650 cells. That's what I bought it for. But you can measure all kind of lithium iron cells with this one as well. So it doesn't matter. It doesn't matter if it's like these mobile phone batteries, lithium iron batteries, or recycled laptop batteries, or these 18650 batteries coming from a scooter. As long as it is nickel metal hydride, nickel cadmium, 3.7 lithium iron batteries, including 26665, 26665, 26500, 18650, 18490, 17. Well, it's all on the back, you know. It doesn't matter what kind of lithium iron battery you're testing. This works with this tester. This one cannot do lithium iron phosphate batteries. It's only lithium ion. I don't know why they make this so close together. Lithium ion, lithium iron. That sounds almost the same, but this is only for lithium ion, ion, not for lithium iron. LIFE, that's not what this one can do. This is only for LIION, lithium ion. Stupid, right? Okay, let me just quickly show you how this works. Positive, it comes alive, so you can see the actual display. And then you put your whatever battery it is in the charger. Show the display. And it sits on charge right now. And with the mode button, you can actually turn this one to fast test or to NOR test. NOR test is the better one. Always use the NOR test. It shows you the actual voltage. Oh, this one is a bit low here, huh? It shows you the actual voltage of the cell, the internal resistance, and then it measures the capacity. The capacity, well, what it does, it charges the cell to 4.2 volts, maximum lithium ion voltage, lithium ion voltage, yes, 4.2 volts. And then it discharges the cell to about 3 volts and measures the energy you can get out of the battery and calculates it to the time, and over time it shows you the milliampere hours, so the capacity of the cell. And this is exactly what I have done with all these cells here. Yeah, well, this runs now from my solar system here. Isn't that great? Yeah, this capacity measurement is a fairly lengthy process. It can take several hours, depends on the capacity of your cell you're measuring. So this took me around 4 weeks to complete. And because it's running from solar, I can only test 2 or 3 cells at the same time. Otherwise, this capacity is not as good anymore, so I cannot, it does not work as well anymore. Well, and then you get all the results. So I've marked all the cells with date, capacity, and internal resistance. So how do we make a battery out of that which can replace 2 of these lead acid batteries here, these AGM or gel batteries? How do we do that? Because obviously this is a 12 volt battery, 7 ampere hours, and we've got 2 in series. I'm serious. This is another word, series, and series. Is so close together and it makes it so hard. Well, how do we put these ones together in a useful way to make a 24 volt battery out of that? AGM batteries, they have a cell voltage of 1.8 to 2.5 volts around. Lithium ion battery, 3 volt to 4.2 volts. So this is totally different. And usually in these batteries there are 6 cells in here, and this makes then a 12 volt battery of 10.8 to about 15 volts. So this depends a bit on your chemistry you have in the battery. And here comes the problem. Because we have different voltages now for each cell, I cannot just use 3 lithium ion batteries and put them in series to get a 12 volt system, because this would result in a battery with 9 volt to 12.6 volt. And you can see the difference here. That is not good enough. So we are a little bit on the low side of things, right? If I take another one and make a 4S system, 4 in series, we will have 12 volts to 16.8 volts. And this is not ideal either. It doesn't really match the 12 volt battery of the lead acid, which is in the solar gate at the moment. Neither a 3S or a 4S is ideal to replace, to make a 12 volt battery out of lithium ion. And that's why most people build a 24 volt system with lithium ion batteries. A 24 volt lead acid battery would have 21.6 to about 30 volts, while a 24 volt lithium ion, and this actually consists of 7 batteries, 1, 2, 3, 4, 5, 6, 7, yeah, of 7 batteries in series. So we are taking not 3 and not 4, so we are taking basically 3.5 for making a 24 volt system. So 7 in a row gives us 21 to 29.4. And look how close this is to an AGM or lead acid battery. This is very, very good. So again, very hard to build a 12 volt system with these batteries, but fairly easy to build a 24 volt system. So we need 7 batteries. So, and here comes the next problem. We've got around 7 ampere hours of capacity in these lead acid batteries, but these ones have measured only 1.7, 1.739, 1.715, 1.781, 1.718, 1.73. They are all different. They're all different. And of course, a 1.7 is far less than 7 ampere hours, so they would be empty in no time. So obviously we need more batteries and put them in parallel. So if I would put these 2 batteries in parallel, the capacity would add up. So 1.723 plus 1.702. And we have about 3.4 ampere hours already with these 2 batteries. So almost half the capacity of this lead acid battery. So if we keep going and put them in parallel, we would have 1.7, 1.7, 1.7, 1.7. 4 of them parallel would give us around 6.8 ampere hours. And we've got 7 in here. So 4 of them in parallel would be ideal. This would be the same capacity as in here. But again, we can only use half of this capacity here if we want them to live a little bit longer. While we can utilize almost the full capacity in these batteries here without harming them. This is the main advantage of lithium-ion batteries. But of course I've got heaps of more batteries. If we would use only 4 of them in parallel, we would be done in no time. I've got heaps of them and I want to use them all. Well, we just found out we can put 7 batteries of the lithium-ion in series to build a 24-volt battery. So this is called a 7S because we're putting 7 batteries in series. How many batteries can we put in parallel now to increase the capacity of this whole system? Well, this solely depends on how many batteries you have. And I just counted them. We have 57 batteries. So 57 batteries we have, and we need 7 in series. So this one divided by 7. This doesn't work. Ah, yeah, this is 8. 7 times 8 is 56. And we've got 1 left. This is perfect because you see these stacks? I've got 1 battery here. This has only 1250 milliampere hours. And look at this. This is all very blown. It looks like it's getting really wobbly. So this one is not straight anymore. I think this is a really faulty cell because all the other cells, they are perfectly flat and there's no doming and this is very typical for faulty cells. They increase in volume and they just expand. See how thick this is? So we don't want to use this cell anyway. So then we've got 56 cells here, perfect. So we can put 8 in parallel and then 7 in series. And because we do that, it's called a 7S8P battery. So this is what we are going to build. 7 in series, 8 in parallel. Well, so how do you start building a battery out of these single cells here? Well, there are two different methods to do it, and I'll show you the wrong one first. So don't do that what I'm showing you now. Don't even look, just don't do that. So you put these batteries, this is just a 3S now, we've got 3 cells, just as an example. So you put all these batteries in series and then have another string with series batteries and then have another string with batteries in series mode. And then you put them all in parallel. You've got your main positive and your main negative. But this is not how you build a battery. This would be bad. You cannot control single voltages of these cells here. You would need a battery management system for each of these strings. And because we've got an 8P system, we've got 8 of these strings in parallel, we would need 8 where's the BMS here? Where is it? Ah, here it is. Yeah, here's our BMS we want to use for this battery. And you would need 8 of them, 8 of these electronics to control this battery. So this is not how you build it. Let me wrong. Don't do it. Okay, don't do it like this. So what you have to do is instead you have to put all the cells in parallel first. So connect all the positives of your 8 battery cells together and all the negatives of all your battery cells together. And do this 7 times because we've got an 8P, so 8 batteries in parallel and then 7 in series. So we've got 7 of these parallel batteries. And then you connect them in series. I'm serious. And in this case, this whole parallel connection here, this acts as one cell. It doesn't really matter for the BMS how many cells you've got in parallel here, because it can see only one cell with this capacity. And because of that, we need only one electronic which controls 7 cells in series. So this is the correct way to build a battery. You need to start. See, this is the stupid thing. They always call the batteries 7S 8P batteries. It should be the other way around, to make clear you put them in parallel first and then in series. But they always called 6S 100P or something, but not 100P and 6S. I think this is very confusing for beginners, but you need to understand that you put the P first when you start putting them together. So always parallel your cells first and then put these parallel cells in series with the other cells. This is the only way you do it. Okay, so far the theoretical part of this video. Probably I make a second video actually build the battery, because this took already a lot longer than expected, but there's so much to talk about and so much to understand before you start building a battery out of single cells. And it doesn't matter if you have the 18650 lithium iron cells, or if you have used laptop batteries here, small ones, you know, you can put them together and build your own battery bank as per your needs. Well, and before we actually start building one, here is the tricky part. Here comes this is what takes a lot of time to do now. Well, we've got 8 batteries in parallel. We're building a 7S 8P battery. So we've got 8 cells in parallel, and then we've got another 8 cells. And as I said before, all these parallel connections here, they act as one battery. And because they are all linked in series afterwards, you need to make sure that the capacity of these single battery cells here, of these single parallel cell connections, so the capacity of these cells should be exactly the same as the capacity of these cells, and should be exactly the same as the capacity here. And this is where it gets so tricky now, because as you can see, we've got 1598, 1664, 1705. So, and then I've got another 53 cells there. How do I match this, that they are all the same when I put them in parallel? Well, I think we leave this video here as it is for the moment. You've got all the theoretical part done. You know what we will do, you know what's going to happen. And I will see you in the next video when we do the manual, calculation and building our battery pack, a 7S 8P. Alright guys, so far this little tutorial again here. Thank you so much for watching, and we shall see us again in the next video soon. Thanks for watching guys. See you then. Bye bye. Just go outside and enjoy the weather.